Yes, how are you everyone? Uh, for today, remember we started a new topic in physics. The new topic in physics. Today we need to look at electrical circuit, also the electromotive force, which is also known as uh, voltage or potential difference. So, under current, they are saying when we use electrical appliances, electric current flows in the circuit. So in the short way, we can say current just the flow of charge in a circuit. So when we use electrical appliances, electrical current flows in the circuit, or we say the rate of flow of charge in a circuit. The flowing current means that the electrons flow in a circuit. So when those electrons, the charges, when they flow in that circuit, you can say it's what? A current. It's a current. So there's a question there. Question 1 says a motor uses a current of 20 amps, that is current, for 10 seconds. How much charge flows through it? How much charge flows through it? So this is our question. But before we answer, let's also look at the electromotive force, or EMF, which is electromotive force. Remember I said it's also known as a what? A voltage. So they're saying the electromotive force of a cell or battery is defined as the energy supplied to each coulomb of charge within it. The energy supplied to each coulomb of charge within it. That's what? Electromotive force. Then you also have potential difference. The energy is carried by a charge from a cell or battery. So what is this charge that you are talking about? These are the electrons, the positive charge. Remember in chemistry we said electrons, the number of electrons and protons are just the same. So you can say electrons or the positive charge are just the same. So they're saying the energy which is being carried by charge from a cell or battery is consumed in electrical components like resistor, lamp, bulb, or heater of a circuit. So potential energy or the voltage, just you can see just the energy which is being carried, or the charge, the energy which is being carried by charge, by the electrons from a cell or a battery to another electrical appliances, anything that uses power like bulbs, resistors, lamps, what else can we say? Pressure cooker, stoves, those things are the example. So they're saying, example, when current flows here, when current flows through heat energy, through the bulbs, when the current flows through the bulb in a circuit, their energy is converted to light and heat energy. So when that current flows in the bulbs, the energy is being converted, light energy and what? Heat energy. If you try to touch those bulbs, you can see that they are heating. There is that energy. There is light energy there and heat energy. Again, they are saying this consumed energy is called the potential difference across across the component. So the potential difference PD is defined as energy converted per unit charge passing through a component. When we start looking at power, like how we say 1 unit is equal to this, like 1000 kilowatts That's when we're going to understand well about this potential difference or voltage. Also have these questions there. We have these questions that saying 40 charge, 40 C means charge of charge flow through a bulb which transfers 180 joules, which is energy, into light. What is the potential difference? So they're saying what is the potential difference? So these are the questions. So so we can begin to solve these questions. We can start to solve these questions. Let's start with question 1. Start with question 1. This is our question. So question 1, it comes from the topic, it comes from under current. That's saying a motor uses a current of 20 amps or ampere for 10 seconds. How much charge flows through it? So one thing that you need to know, you need to write the formula for current. Current. They are saying, we say current is equal to charge, which is Q. We can say C, that's a symbol, but under the formula they are using Q as charge over time. So also you need to know that current, the symbol is I. We say current, the SI unit is ampere. Ampere, which is A. This is our symbol, or the SI unit. Also to know the charge, which is Q, that's saying charge. It's the charge. The SI unit is coulomb. Coulomb. And the symbol it's what? C. That's the SI unit. Then another thing is time. We know time. Time. The SI unit there you can say it's seconds. It's seconds. So the question, the first thing that we need to do, we correct our data. We can say our data. When we read our question, a motor uses a current of 20 amps. So we know that current is equal to 20 amps. What else? We need also the charge. The charge we don't know. We can do this. The charge we don't know. Another thing, we can say in our question there is time. Say time is equal to how many? 10 seconds. This is our time. So this is our time. Then, now we can say to our formula, see they are saying how much charge flows. How much charge, they are saying how much charge flows through it. So they are asking us to find the charge. So we can say our formula, current is equal to charge over time. Then you can just substitute the values that we have. If you have difficulties in making Q the subject of the formula, you can use just substitute the values. But here we can say charge is equal to current multiplied by time. Or we just use this one, substitute the value that we have. Current we have 20. That's the charge. That's the charge current that we have. Then it's equal to our charge we don't know. It's the one that we are looking for. Over What's time? It's 8. It's 10. Then we can cross multiply this. There is 1. You can say charge is equal to 10 times 20, which is 200. Coulomb, we can say C. So that's our answer for question 1. That's our answer for question 1. Then another question comes from voltage, the potential difference. The potential difference. So this is our question. They are saying question 1. This was question 1. Let's say 1. This one was example. So you can say under potential difference. Potential difference. Now the question. The question says 60 charge. So we need to correct our data there first thing. We say our data. We have charge. The first thing they are saying 60 charge. You can say Q. Then we can say Q or charge is equal to 60. That's the charge that we have. Another thing they are saying, we have the charge flow through a bulb with which transfers 180 joules of energy. You have energy. We can say energy is equal to, that's saying 180 joules. That's the energy. Then what else do we have in our question? Then they're saying what is the potential difference? The potential difference there, we said that is same as voltage, of which we don't know. So under voltage, the formula that we use, we can say potential difference PD or voltage is equal to, we can say energy over the charge, the amount of energy supplied in electrical appliance. So we can say, since our data we have, we can say voltage. We know that the SI unit for voltage, it's V. It's V, volts, or say volts. And the instrument that can be used to measure voltage, it's a voltmeter. The instrument that can be used to measure current there, what you say there, current, you can say it's an ammeter. So now our question says, let's calculate for potential difference or electromotive force or voltage. We can say V is equal to NH. What's the NH? You have 180 there. It's a 180 joules over the charge. Now it's what? A 60 coulomb. Then you can say voltage is equal to 0 there, cancels this 0. Then we can say 6 into 18, it's 3 what? Volts. That's our answer. This was question, which question is this? This was question 1. This was question 1. This one was question 1. Then there's also question 2. So this was question 1. Also have question 2. So what's the question? If we check question 2, they're saying when a current of 2.5, the current of 2.5, the current of 2.5 flows for 8 seconds, that's the time, through a bulb and have energy which is 270 joules of energy are consumed. When a current of 2.5 ampere flows for 8 seconds through a bulb, the energy which is 240 joules is consumed. Then question A, how much charge flows through the bulb? Question B, what is the potential difference across the bulb? So let's correct our data there. We have current, time, and energy. Our data. We have current. That's saying it's 2.5 amps. We also have time, which is 8 seconds. Also have energy, which is 240 joules. If I'm not mistaken, that's the energy that I've seen here. It's 240 joules. It's 240 joules. That's the energy. So coming to our question. They are saying question 1A. Is it question 1? Question 2. Question 2A. How much charge flows through the bulb? The charge now. So we can say a charge which is Q, we don't know. So which formula can we use? If you use this one for voltage, it can't work because we don't have voltage. So the proper formula that you can use there, this was question 2A. We can say the same formula we use, that the first current is equal to charge over time. And we want to find the charge. Since the current we have, it's here, 2.5. Time also we have. So what can we do? We're going to say charge. Current is 2.5. Is equal to charge we don't know. Time it's 8. We cross multiplication. We cross, what can we find? What's the value? When we use the greater, 2.5 times 8. 2.5 times 8. We're getting a 20. So I can say charge, since there is one here, I can say charge is equal to 20 coulomb. That's our answer. Then B, they're saying find the potential difference. So we can say voltage is equal to energy that was consumed over charge. Since the charge we have, we can say voltage is equal to energy, which is 240 joules, over charge it's 20 coulomb. So we divide there and there. We say V is equal to 24 divided by 2, which is 12. 12 volts. So these were the answers that were expected for us to find. So if there is any question, please feel free to post in the group. Thank you.